Okay, so our next talk for this session, so this will be the last one of this session, is going to be Anand. He's going to be talking about managing machine learning models in production. So if I give it for Anand.
Hello, can you hear me in the back? Yeah, okay. Good afternoon. Okay, so I'm going to talk about machine learning, the challenges in managing machine learning models in production. So let me start with introducing myself. My name is Anand. I'm co-founder of a startup called Roro Data. We're trying to build a data science platform. I also do advanced programming courses at People Academy. This talk is going to be like twofolds. One is we're going to talk about the challenges in managing ML in production, and the second part I'm going to talk about what we are trying to do to solve those kind of issues. So, as part of my work, I interact with a lot of startups and businesses trying to do ML, and I kind of see the same kind of patterns repeating again and again. Usually there's a lot of technical debt, and there are some issues like people want to fix, but they don't have time to do those things because that's not really the core of their business. So I'm going to kind of go through like some of the key challenges that I find it really common to many people. So when people start using machine learning in production, these are the couple of things that kind of I found the common across all the people that I've seen. So one is managing models. So when people start doing machine learning, they start with a couple of models, but over time and with the team sizes, the number of models grow, and it really becomes too difficult to actually figure out what went in building each model. So what happens, so that's one big thing. It's really not a data science challenge, it's more a bookkeeping challenge. And the second thing is collaboration. As more people start working in the team, how do people work together? How do people share these models across the teams, etc.? And the other real pain point is infrastructure provisioning and deploying models as services and doing quick experimentations with whatever that's been built. So let me dive into each one of them. So if you look at the model management, as people build models, maintaining multiple versions of the same machine learning model is kind of difficult. The other thing is when you build the model, you want to know what exactly went into building the model. Where is the which is the data source that came in, and then how much accuracy you've got. For example, you want to go through the evolution of the model, how the model has been evolved. It's really hard. So one of the experience that I had is someone was telling me they get new people joining the team, and they come and say, why don't you try this approach? I think this approach will work. This will actually give better performance. But these people have tried those approaches, but it's really hard to tell what exactly they have tried and how much accuracy they've got, or why that actually didn't fail. So what usually happens is people tend to repeat the same patterns again and again because there's no record of what actually went in building that. So that's one challenge. The other is collaboration. Sharing models with others in the team is one big challenge because unless you have a centralized place where you keep all your models, it's going to become difficult for people. For example, what people usually, at least unless there is some kind of infrastructure in place, what people do is build a model, keep it them, and then once they're done with building the model, they kind of put into production. But they're usually noticing there's not a place where people can share things easily and using models across the teams. And once, even if you have some way of doing it, having access control, etc., is going to be again painful. The next challenge is deploying. So once, let's say you have a machine learning model, how do you deploy that as a service? So what ends up happening is the same kind of approach is being done, repeated across for each and every machine learning model that's built. And keeping track of usage and latencies for deployed models is again one more challenge. I think the infrastructure is one of the biggest challenges I usually see. Starting instance on demand. So what many people do, at least in the beginning of their data science evolution, is they allocate some resources for the team because that's easy for managing billing and all that. So people are constrained by whatever resources are available to them. So it will be really nice to have a way to start instance on demand so that people can start using whenever they need. Also, that kind of helps in resource utilization. The other challenges are doing a quick experimentation. For example, you wanted to know whether this model is going to work or not. Having the right abstractions to do things like A/B testing, etc., would be really, really helpful. So here is what the word claim I want to make is the pace of innovation in a data-driven business is really limited by the bottlenecks in the data science workflows. The reason is, the bottom line is here, you may say a lot of these things actually like save time or save some money, but the bottom line when you look at it is what it really affects is the time to market. So when you have a business, you are trying to use data science there, if all the challenges, what they really hurt is the time it takes to market your product. So this is really, really important to actually make sure that the challenges are not there. So, so that's those are the kind of challenges that we usually see. And so what we are trying to do is we're trying to build a platform to kind of solve these kind of issues. So let me kind of give a brief about what we are trying to do here. So we have built a data science platform to solve these issues. One of the key elements of our platform are, so we have a tool for doing model versioning. We have a tool for running Python functions as a RESTful API and a compute environment to deploy models, run notebooks, etc. Now, let's look at the model versioning part. So it's really, so if we look at when you want to model multiple versions of machine learning models, the key things are you want to store them in a common place so that all of them are available somewhere and then people can, all of them can access at the same time. And then associate the metadata along with the model. So when it's a metadata, you may want to attach anything about what went in building the model and then how good the model performed and all those kind of things. And then the other important thing is to have a simple API that data scientists can actually use it on their own. So if you look at the way what we've done is we have an idea of something called a model repository, which is for storing multiple versions of a single machine learning model. And we call this thing called a model image. It's saved version of model plus its metadata. So that's we call a model image. So this is how it looks like. So we have a model repository which has multiple versions of models, and version 1 has the model and then its metadata, and model image 2 has model 2 and its metadata. That's how it looks like. Now if you look at the metadata, it's important to capture everything that went into building the models, including who built it, what the data set that's actually used, what are the features used in building the model, what was accuracy, and if you even look at which algorithm is used, what are the parameters passed to the algorithm. It's good to capture everything that's possible along with that. So here is a sample metadata. I hope you can read that. So it has the author who created the model, when was it built, what encoding is used to actually save the model, where the input came from, what Python version was used, what are the data set features used, how many rows are there, what algorithm used, what are the training parameters, how much accuracy you have got, and you have run in some system which has a job ID so that you can go back and look at the logs if required. So that would have a link to some other system where you have other information about it. So these are all things you can actually capture as part of metadata. So just to look at the Python interface that we just have a you get the project, and then from the project get the model repository, and then get an image, and then you can print all the accuracies. For example, you want to print how the accuracy has been evolving, you can get all the versions and then print the model version and the accuracy like that. When you're saving the model, you can do the same thing, but you create a model image and add all the metadata that you want to do it. So you so that the new image creates a new model image, and then you can use it like a dictionary and then add any key value pairs that you want it, and then commit with a comment. So that saves the model. It saves a new version of model. So we provided command interface for accessing this. When you say modal list, it lists all the modals, how many, what's the most recent version of the modal. Or you can download it or tag different modals, give a tag to that. So it provides a Git-like interface for logging. Look at the log. So you can say modals log. It looks at, it shows the log of what all went in building it. So there could be multiple modals in the same project. So it will tell you according to time what's modal ID, what version, and then the comment about what went into building it. It also allows looking at all the details of the metadata that went into each of those images. So, so we realize that having a tool like this really helps a lot in keeping track of everything that went into that model. So that's the first tool that we've built. And the other tool that we have built is called Firefly. So it's a tool that's used to deploy machine learning models. So if you look at the problem, how do you expose machine learning model as an API for others to use? Or simply if you look at, given a Python function, how do you expose it an API? So the challenges are it requires writing a web application, doing authentication, and taking care of validation, etc. And once that's done, to use it, you need to have some kind of client library again. So, and this is not a one-time job, but it's something that you have to repeat again and again for every time you are deploying any machine learning model. So what we've done is we've created this tool called Firefly to make deploying functions very easy. The way it works is you write a Python function, let's say call it square, and then say Firefly sq.square, module name dot function name, that starts giving you an API. And you can take a client and then create a client and then call the function from the client. So that gives you same, that basically calls that thing through the API and then gives back the response. Behind the scenes, it's actually a REST API. Excuse me. Behind the scenes, it's a REST API. So you can send the data as a post request, and that gets back the response. As long as the function supports JSON-friendly types, you should be able to use it. Now, let's look at a simple example of deploying an ML model. So you load the model first, and then write a predict function that takes all the features, and then gives that back. All you have to do is Firefly model.predict that starts the server, and then create a client, and then start using it. Now, let's skip this for now. So the other good thing is it's an open source tool. You can actually go and then try it out. Now, so these two actually solves a couple of challenges that I've talked about. The other most important challenge that we're trying to solve is the infrastructure challenge. So I built a compute platform for doing that. So if you look at the infrastructure, the challenges are setting up the right environment and provisioning the server as required to serve all these functions. So if you look at the abstraction that we're trying to create is, we're trying to create an elastic computer for every project. What does it mean is, when we look at infrastructure provisioning, etc., we usually talk about start a server and then run the job, etc. But what I'm trying to do here is to see if, can we think of an elastic computer that has infinite compute capacity, infinite memory, as much as you want, okay? Just like your laptop, but that never gets slowed down. You can run as many jobs as you want, okay? So run this, that starts running it. So it's an elastic computer that kind of grows as per the needs. So if you have something like that, the data scientists can just focus on running their jobs without really having to worry about starting servers, stopping them, or et cetera, et cetera. So when I say project, what I mean is just as a unique name, it specifies runtime, what's the base compute environment that you want to use with Python 3 scikit or Python 3 keras, etc. And then you have your code, and then all the services and scheduled tasks. When you say services, you want to deploy a model as an API, or you wanted to have a dashboard that you wanted to serve as part of the project, or you want to schedule periodic tasks to run every day, nightly, I want to run a training or something. And you also need to store your data, so we have a place for storing data volumes. So start with the setup. The way it works is you specify the project And what's the runtime? So his project name is credit risk, and the runtime is Python 3. Specify the services. Say I want the default service is a function to call that's predict.predict. So predict is module name, and predict is the second predict is a function. You can also specify the size of the instance required, and there are 2 services here. And you can also specify the periodic tasks. So every day at 10 a.m. I want to run train.py, so that takes from there and then runs the periodic tasks. And the way you deploy, you say deploy, and then it actually takes the code from the current directory, sends to the server that actually does everything required behind the scenes. It builds a Docker image, installs all the requirements.txt, and then starts all the services that are required. It also allows to run notebooks. For example, you want to run, you're running training, you realize that the memory is not enough, you can start a bigger instance or something, or start notebooks as well. It allows you to inspect what's running, etc. You can look at the logs of any of the jobs. For example, if the program is running training and training is printing some of those logs, you can look at the logs and then inspect what's actually going on. So, so having a platform like that kind of opens up a lot more opportunities. For example, it's really easy to record and monitor model predictions and performance. It's also becomes easy because the models are saved in a central repository, and each can be identified with a version number. So doing things like A/B testing becomes really, really easy. So let me summarize. The managing machine learning models in production is not trivial, and the pace of innovation in data-driven business is limited by the bottlenecks in data science workflows. So having data science platforms are essential to fill that gap. Either you have to use the data science platform, or you have to build something like that. Okay. So, but having the right kind of abstraction is really, really essential. Yeah. So, thank you, and these are the links for my slides. I'm open for questions if you have any.
Yep, there's plenty within time. Okay, do we have any questions for Anand about this topic? Yes, hang on, I'll bring over really? No, you get to experience the mic.
Cheers. So, the easiest thing to put this, you would be able to have like a repo of models, right?
Sorry?
So virtually, where you perfect your model and you deploy a new version,
okay,
would you be able to go back and diff the 2 models? So you have your A/B testing, and okay, would you be able to drill down to see exactly where the difference is coming from?
I guess, could you please repeat the question? I didn't,
So you virtually end up with loads of versions of the same model, slightly tweaked.
Yes.
And you say, let's say you have V1 and you have V10. Can you go back and diff the 2 versions and essentially drill down on exact the 2 differences?
Yes, you can. So there is an API to get each of the models that you want. So, so it's basically storing them and then giving you access to any of those models. So I guess I'm not sure if I got the question. So will you be able to access the old versions? Yes, you can access them and then get and do whatever you want with the model, any of the versions.
Okay, any more questions? Yep.
Thanks for the talk, it's really interesting. Does the system work cross-platform? So if you've got some people on one environment and some on another, they can collaborate together?
Yeah, so the thing is, this actually works at a project level. So what we're trying to do is each project is independent, and then multiple people can collaborate on projects. So that's the idea. Okay. So at a project level, people can collaborate.
Okay, so let's thank Anand again for that talk. Thank you very much.
Thank you.